Hi, everyone, and welcome to the third season of Additive Talks. If you are joining us for the first time, make yourself comfortable. Additive Talks are simply a series of panels that focuses on discussing the use of additive manufacturing technologies in a given industry. No pitches, just lessons, mistakes made throughout the adoption curve, and new opportunities. If you have been here before, thank you for listening to our insight into the world of AM. My name is Katie Sinze, managing editor at 3D Adept Media, and your host during this session. I will now give the floor to our guests so that they can introduce themselves and the company they represent. Martin, welcome back.
Hello,
Yeah.
everyone. Hello, everyone. Sorry.
Martin,
My
please
name's Martin.
tell
My
us.
name's
Tell us
Martin
a little
Stevens.
bit.
Sure.
Yeah.
So I work for Deutsche Bahn Engineering Support Group.
Yeah.
We are part of the engineering arm of the big Deutsche
Okay.
Bahn Railway Group, based in the UK,
Mm-hmm.
and we are, and I lead the additive manufacturing working stream there. So we've been working with a company called Angel Trains in the UK for quite some time now, since 2018.
Mm-hmm.
And we are pushing additive in the UK.
All right. Thanks, Martin. What about you, Anthony?
Hi,
Good morning.
everyone. Hi, good afternoon, good morning, good afternoon, good evening, everyone. Thanks for coming along to hear Martin and I's pitch here and just some items as we go through with Kezi. So I'm based in Pittsburgh, Pennsylvania. I'm the global additive manufacturing leader for Wabtec Corporation. Wabtec is a global rail leader, and what my mission is to help continue the mission of additive throughout our company, is to integrating additive into our Wabtec product portfolio. I'm a career-long additive enthusiast. Spent the past 10 years or so in additive manufacturing in a variety of roles. So excited to share my learnings and just a few thoughts with you today.
Thank you very much, Anthony. So we are going to talk about the rail industry, obviously, and in a context where more and more heavy industries realize the potential of additive manufacturing for their production needs on the one hand, and where each of these sectors comes share of requirements. So, Martin, we'll start with you. How do you define the right time to shift one's business model to AM?
Well, I'm not sure it is a shift, as in
Okay.
a single shift. I
Oh,
think it's more of a gradual increase in capabilities,
okay.
because we treat additive manufacturing as another tool that we use. So it's a complementary tool to the traditional processes.
Okay.
And bear in mind that additive itself isn't just one thing. It's lots of different things. FFF thermoplastic, for example, it's a very
Mhm.
different business model to SLM aluminium or DED steel. So
Okay.
really, it's a continuous progressive expansion of capabilities as we move into the additive world. In terms of timing, right now is the time, because the first steps you could do, there's almost certainly some use cases right now that would work with the techniques that are available at the moment.
Okay.
So not a big step change, but
Okay.
a learning step by step, introducing more and more capability into your business model. And the more you involve yourself, the more you find use cases that work.
All right. Well, speaking of use cases or business models, to tap into the potential of additive manufacturing, rare companies especially seem to focus their activities on the simplification of their supply chain with 3D printed spare parts. So, Anthony, do you think is the only this is the only business case that may enable you guys to stay competitive on the market while leveraging AM?
Great question. Yeah. So we recognize this exciting technology, these machines that are really game changing,
Okay.
and oftentimes people who aren't aware is like, okay, cool, but how am I going to use it? Like, this is where the rubber meets the road, right? Like, how do we actually make these into a solid business case, right?
Yeah.
The question is, Is spares the only avenue for that? No, definitely not. I think spares is definitely an avenue, but one that you should consider along with many others that I'll touch on.
Okay.
To touch on spares, first of all, is it's not just kind of like a static equation where it's like, does it make sense today and tomorrow it still does not? It's ever evolving and changing.
Mhm.
That's to take a look at the past 2 years of the pandemic and the kind of the restrictions around our supply chain. The opportunity for additive has just increased for spares because lead times have gotten longer and longer.
Mhm.
So if you do this assessment today, it's going to change tomorrow, especially not only to the speed of the technology and how it's advancing, but to the global state of affairs and what's going on in the world. So that's spares, and again, definitely an avenue that we're evaluating always within Wabtec.
Mhm.
But it's everywhere along that product development cycle that you can assess. It's a
Okay.
prototype. Prototypes still have value, and that's the area that's been used for the past 20, 30 years, and we continue to use that where it makes sense.
Okay.
Um, it's spares, it's fixturing, it's bridge manufacturing. If I can't get a tool until 6 months, a year from now, how do I ramp up into this? You can in theory use additive, and
Okay.
then the whole way to production. Serial production is one area that I'm positioning my team, and
Mhm.
we're looking to continue facing in towards because that's where we believe it gets your optimal performance out of the technology.
Okay.
It's this great, exciting technology. Cool. How do I get the most out of it? Well, you're using the technology for what it was designed for, optimizing these complex shapes, flow channels, the organic shapes that you may see in the headlines. That's the stuff that we're looking towards. And how do we make Wabtec product and therefore our customer products better?
Okay.
That's the kind of the top right area.
Okay. Just for the context, does Wabtec use AM just for everything related to the rail industry, or I mean, do you guys explore the technologies across other departments? Just for us to know.
So Wabtec is primarily kind of a rail user. We sell products into other, I would say, heavy industrial areas in
Okay.
which we supply those as well. So it's not strictly just rail, but the majority of our business is rail. So yes and no,
Okay.
but it revolves around industrial components.
Okay, all right. So let's provide a context for our audience right now. But regarding the railway industry, traditionally, what have been some of the biggest challenges in rail production? Both of you are going to answer this question. So I will start with Martin.
I think the biggest challenge is really that rail orders are very low quantities. You
Very low
don't
quantities. Okay.
it's not like a car where you build millions of the same car.
Mm-hmm.
A single order that might be 200 million pounds
Mm-hmm.
might only get 20 trains, so
Mm-hmm.
that would have 40 cabs on it. So
Okay.
a 200 million pound order only needs a
Mm-hmm.
run of 40 parts.
Yeah.
And traditional manufacturing isn't really very good at such tiny quantities.
Okay.
So effectively, every train is bespoke
Yeah.
in that context. And that traditionally is a big challenge. And it's really why additive manufacturing really should be great for rail.
Okay. All right. Before Anthony, before you respond to the questions, just a quick reminder for our audience. Uh, Please feel free to send us your questions in the Q&A chat in front of your screen. We'll make them publish. We'll pause at some point and read them so that Martin and Anthony can, respond to any of them. So really, any questions or even any remarks, everything is welcome. Yeah, this is a space where everyone should be able to talk freely. So yeah, Anthony, go ahead, please.
Sure. So kind of I'll take it of the context of like the intersection of additive and the traditional kind of challenges that have been present in rail, right?
Yeah.
So how do we continue kind of bringing kind of rail into additive and vice versa? I
Mhm.
think the big things revolve always around, and I said before, is business case, and the second item is education.
Okay.
Education doesn't matter rail or any other industry. How do we continue to increase the awareness and integration of additive? It
Mm-hmm.
comes back to education.
Okay.
Um, Engineers have been trained up for the past year, decade, multiple decades around designing parts around certain conditions.
Yeah.
And we're throwing into the lab this new technology and process that changes a lot.
Mm-hmm.
So we need to properly educate to get the optimal output out of it.
Mm-hmm.
So education is a big one.
Okay.
Business case, the first one I mentioned is that rail has been around for many, many decades.
Mm-hmm.
I just mentioned it's like the costs have been optimized in a lot of the traditional manufacturing techniques.
Mm-hmm.
So it's tough for a new technology and one that's, well, frankly, expensive
Mm-hmm.
compared to a machining operation or cast operation to
Yeah.
compete with that. So the business case are most of the time challenging. So we need to find areas of like, it's not always it's cost, but it's system level cost. It's not just your part to part replacement. So you have to
Yeah.
assess your whole system.
Okay.
So business case, education, definitely I would say the biggest challenges kind of on that converging point between rail and additive.
Okay. Okay, I see. But when we talk about applications, Anthony, do we mainly talk about polymers or metals?
Yeah. So for it's different for everybody. Really, what we do is we look at our product portfolio in Wabtec.
Mm-hmm.
What are the parts that we're making? It's both polymer and metal.
Okay.
It's heavier on the metal side. We make freight equipment, so it's locomotive engines and
Yeah.
then transit components. So the majority of those products are metal. So we've invested heavily on the metal side.
Okay.
However, a lot of the products we do sell some products on the polymer side as well, especially on the transit component side.
Yeah.
So we've invested in polymers as well. I
Okay.
wouldn't say it's as heavy of a strategy
Yeah.
and path for us as the metal side, but it's definitely a value stream that we're pouring into in our investment around additive.
All right. What about you, Martin? How does it look like at our DB?
So yeah, we don't have the budget to invest in our own machines or things
Okay.
like that.
Yes.
So we're relying on print bureaus and we're relying on the
Yeah.
technologies that are widely available. So our focus has been on polymers
Okay.
primarily.
All right.
We do want to do metal because exactly as Anthony said, a huge part of rail is metal because it is a heavy industry.
Okay.
And DED technologies are starting to get maturing enough now
Okay.
that I think they're going to be the next big thing to look at.
All right. All right. Okay. So I mean in general, do you think that Martin, that these applications require to completely redesign the parts or just to repurpose the design for a new function?
Both, I think. I mean,
Okay.
um, firstly, if we're talking about spares, then we generally have to keep the design very similar. So
Okay.
we'll make some small adjustments to
Okay.
align it with the additive technology and optimize the value. So we
Okay.
might add internal cavities,
Okay.
reduce the material usage, change a few parameters, etc.
All right.
Or take the advantage to correct a design flaw at
Okay.
that point. But the other advantage of additive, as Anthony said earlier, is that you get the complete freedom of changing your design completely, going generative design and things.
All
So
right.
there, when we're talking about a new part, a new design,
Mm-hmm.
then it would be something completely different, and we'd want to leverage the flexibility that additive gives us.
All right. Anthony, do you agree with him?
Yes, every step along the way. Yeah. Martin, you initially kind of said it is around kind of the when do you move into additive, right? And I reference it. It's not just like a static, like here's where it is, and that's the same with regenerative. Like, should I optimize my design for additive or should I
Mm-hmm.
use a traditional design? It really every application is different, and that's sometimes the frustration of the customer end. Every question they ask is, I say, well, it depends.
Yeah.
Like everything is, it depends, and it does. It just depends on your application. Where are you at in that development cycle? Should you
Yeah.
change? Well, there's a cost to that. There's a cost to changing over and optimizing for additive. Is it
Mm.
worth it? So we do a little bit of everything, but again, it just depends on where the customer's coming to us from, dictating where we'll go in that process.
Okay. All right. I see. So let's try to see how companies can adapt your business model with current advances in AM. So most applications right now enabled by AM usually strive to address the challenges raised by their conventional manufacturing process counterparts. So with the continuous development of AM technologies, do you think, Martin, that the adoption of a new process may lie in the ability to address a challenge that another AM process couldn't meet?
Yes, I think so. Let me just think about this question.
Do you want me to clarify it? Maybe I could.
Yeah,
Okay, let me clarify it. So usually when we tend to realize that when when we use AM for a given application, it's usually because a conventional manufacturing process has failed to meet some manufacturing requirements. So that's the basic rule, let's say like this. So right now we have more and more AM technologies that are pop up on the market. Yet most AM technologies that are currently being used by industrials are still the same: LPBF or polymer 3D printing, MGF, etc., etc. So imagine now that we want to adopt new technologies like DED that you mentioned at the beginning of the talk. So what will be the ideal, business case to adopt those new OEM technologies? Can we envision a world where to adopt these new OEM processes like DED, binder jetting, do we have to have like a requirement that LPBF couldn't meet, or MGF? Does my question make sense for both of you?
yes,
Okay, all right.
yeah. So basically, yeah. So the limitations with the current main processes are why we are looking at the newer processes.
Okay.
So take the main one is cost, really. So looking at metal,
Mm-hmm.
if we're going laser sintering, it's an expensive technology.
Yeah,
So
sure.
it's been done in rail. Mobility Goes Additive, which is a European network on additive
Okay.
manufacturing. They did a trial with Hamburg Metro
Mm-hmm.
to print a brake suspension link, which is
Mm-hmm.
a simple component but very arduous
Mm-hmm.
engineering requirements.
Okay.
And they showed it was viable with SLM. Technically, it's viable, but economically, it's just massively too expensive
Okay.
for something like that. So SLM can do it technically, but it's too expensive. But DED now, it's looking like it might be possible to do that at a cost-effective price.
Okay. So what I'm hearing right now is that actually cost is the main factor that actually slows down the adoption of other AM processes. Anthony, what do you think about it?
I think that it slows down kind of the off the shelf adoption for sure.
Okay.
And I say off the shelf, meaning kind of like the current state of affairs of where we're at today. Like
Okay.
how if we were to kind of pause all development, how do we continue the adoption? Well, cost is it's going to be a barrier. It'll be a barrier for a while.
Okay.
Not the only barrier though. There's some limitations around kind of material properties. How do
Mm-hmm.
you know for sure material properties are what you need it to be? There's a lot of testing that occurs. I mean
Mm-hmm.
that you can track ultimately back to cost too, but it's not just that. Goes back to my last point of like it depends, um, but yeah, cost is always kind of a hurdle that we face into.
Okay.
And
So and
size
size.
is, yeah,
Size.
especially when we're talking rail, because what's the build chamber of an SLM machine? It's not 2 meters.
Okay.
And for rail, you might want something that's 2 or 3 meters long to make something as a single piece. So size is another big
Yeah.
factor.
Okay. So, but is there any process that you see as like the next solution to leverage right now? Any specific AM process, AM technology, yeah, that you see
Yeah, wire
as,
arc,
as
wire arc additive manufacturing, the DED
yeah.
methods. There's
Okay.
machines now, WAM UK, they've got a 2 meter squared build chamber. It
Mm-hmm.
can print in mild steel. The costs are coming right down. They're big build speed, big volumes for metal. So
Yeah.
that's
Okay.
definitely of interest to us.
All right. Awesome. Anthony.
Same thing. Martin stole exactly it. DED, yeah, in general DED. Wire
Okay.
arc being one of the, I would say, leading flavors of DED that are coming out of the pack there.
Yes.
DED is interesting because it's been around since like the inception of additive as we know it. It's kind of like the early mid 80s. DED was around that same time frame, and it hasn't, I would say, scaled the same way as we've seen laser powder bed fusion scale, even binder jet to a degree scale. So, and when I say scale, I mean industrial printing. How repeatable is the process?
Yes.
How accessible is it, right?
Mm-hmm.
So all of those things have come a long way, and I would say the past 5 years or so.
Mm-hmm.
So DED is starting to be closer to my phrase around off the shelf. Can I
Okay.
get it and pull it off the shelf, plug it in, and use it in an industrial setting? It's getting much closer to that, and so I would say it's getting more of our interest in how do we best integrate this in, plug this into what we're doing as Wabtec.
Yeah. Okay, I see. Let's pause for a minute, gentlemen. We have a couple of questions too, actually, in our Q&A chat. One of them is from Ian Ramsdale. Ian, I hope I pronounce your name very well. If not, I'm very sorry. Pardon my pronunciation. So Ian is asking, how do you see AM electronics affecting future design and manufacturing capabilities? That's a good question. Maybe a tricky question for my guest.
Yeah. So I'll take a stab at that first.
Okay.
Um, so AM electronics affecting future design manufacturing capabilities. So printed electronics, like again, we've been talking all these different flavors of additive.
Yeah.
There's so many under the umbrella of additive manufacturing technologies, right? Um,
Mm-hmm.
Electronic printing, again, is another one that's getting more and more popular, closer to industrial scale.
Mm-hmm.
What I'll just speak for myself, and I'll maybe probably a little bit of Martin in that. Like again, we're making rail components, so mainly larger type of components. The
Okay.
electronics have been restricted to really like kind of a very low Z, really small parts to make it effective.
Yeah.
So how do I see that scaling? Well, eventually, like they're going to be able to scale the size of that, which will lend itself more closer to the components that in rail of where we play. Um, and then eventually, once that process is optimized, and we'll say laser printing is optimized even more, there can be a potential integration there. I think I would say maybe like a decade away from being really impactful on an industrial scale, maybe a little sooner than that. But it's not like something where I'd be able to leverage that tomorrow. It's a little ways away, but it's definitely something. There's so many exciting things on the horizon. Is one of the many.
Okay. Interesting. Martin, anything to add?
I don't think I have much to add. As Anthony said, it well at ESG we don't really get involved with the electronics design side of things. We integrate electronics into trains
Okay.
or reverse engineer things, but we wouldn't do our own electronics design.
Mm-hmm.
Um,
Yeah. So.
and the other thing is the heavy electromagnetic requirements of rail means you do need quite bulky
Mm-hmm.
components compared to, say, your mobile phone
Okay.
electronics.
Okay.
It's
Uh,
another item that opens up the possibility to continue to expand on that. What can a designer do at his computer and designing to put in the
mhm.
field? It definitely continues to push that envelope, which I didn't say it earlier, but that's kind of like one of the main themes around why I'm in this technology is
Mm-hmm.
because there's no playbook. It's been changing every day for the past
Yes.
10 years since I got in.
Yes.
And this is kind of another little nugget of like example of how it is changing.
Yeah. The book is still being written, actually. Yeah.
Definitely.
Yeah. So I hope this answers your questions, or otherwise, please feel free to ask any other more questions or even share any remarks regarding these responses. Let's move to another question. This one is from Steve. How far have we advanced in the certification of 3D printed parts? This one is, in your field of expertise directly. So,
Yes.
Martin, do you want to start with that?
So there's two things to consider here. There's firstly the part itself, but there's also the material and the process used to develop the part.
Yeah.
So this is especially, we can easily describe this for interior components. Plastics, for example, there's very strict fire compliance requirements in rail. So we need to make sure that anything we make meets the standards, which means that material needs to have certification against the fire tests. Then, once we make the part, we then have to do an additional layer of approvals depending on what the part is. So, just to give you an example, got a nice little armrest, very simple part to make, but that's made from a fire compliant thermoplastic. So we've got to have all that certification, and it also has a structural requirement so that passengers won't break it if they happen to sit on it, for example. So you combine both together to get your final certification. And we have certificated multiple interior parts. In Deutsche Bahn in Germany, they've certificated components that go on the bogie, so high safety critical parts. So we have approvals and operating in service parts from all over the train.
All right. So what does the process look like at Wabtec?
So I'm aware that this is an additive discussion. I hope I don't get thrown off the panel for saying this.
Oh, yeah, feel free. Tell us.
So additive, and I hope this doesn't come as a surprise, but additive is not that special. It is. I love it personally.
Oh gosh, you just hurt my heart right now.
I know. But it's definitely a reality and one that whenever we talk to quality engineers and just any principal engineer, we have this conversation where it's another manufacturing tool.
Yeah.
It's just like any manufacturing technique. It is new. There is variability, but as Martin was saying, if you control your process, your material, and your design, so you know your outcome, you can control that part and what the predictable application, how that will behave. So application's not special in that we just work it within the same process that we have within Wabtec. Yeah. We have so right now we have over 40,000 parts that we've printed that are on asset. So on either our locomotive or transit vehicles. So they're out there in the world and have survived because again, we've just operated under the same quality matrix, under the quality structure that we have in place for Wabtec, making sure we get all the right check marks. Is it like, again, there's more front end stuff because it's a new technology than a cast or a machine or injection mold. But as long as you get those check marks and backing from quality, good, it's good to go.
You know, I want to be honest with you. I'm very surprised by your response right now because, people keep telling us that certification is, really the holy grail of everything related to AM. So coming here and, you make it look like, it's just like a checklist that you have to do. See, you make it really look simple.
If you have an industrial machine, a machine that has like a process window, a box, right?
Yeah.
If you operate within that process window, we have really talented quality engineers across the company that we work with and say, okay, like help me give you the information. Like what else do you need to see? And we, again, form that process window. And again, it's the same as any other manufacturing technique out there.
Okay.
But there is the element of novelty, as in the materials are new.
Thank you, Martin.
You go through the same process, but you've got to get that data that has been in the public domain for years with traditional materials, but it doesn't exist for the new materials. So there's that cost hurdle to overcome to start with for getting that test data, getting that fatigue data, getting that understanding of the process in place.
Completely agree. And on the contrast, if you look back however many years ago, decades, as new materials were cut in a casting process or machine, it was a similar way. Maybe a little different because it's been decades ago, but you get the point where it's if you form a confidence rating upon a certain set of conditions, you know what your application performance is going to be. Still, back to the point, there's definitely upfront barriers we always face. I'm sure Martin and me make it look easy, but this has been many years of experience, and how do we navigate the system, ensure that we're forming appropriate process windows so we're confident in our parts as well.
Okay. All right. Before we move forward, we still have 30 minutes to go before the end of the panel. So if you have any other questions, please feel free to share them in the Q&A chat so that we can still discuss them while we still have time. That's it. So let's continue our discussion. So consider all the stages of the manufacturing value chain, from design to quality assurance and end-use product. What are some of the advances in AM technologies and equipment that have been crucial in reshaping your business model?
I think materials development's been a big one for us.
Okay.
Especially in thermoplastics. Because when we started, there were only two railway fire compliant materials we could use. There was an SLS nylon from EOS, and Stratasys had their Ultim 9085 material. But in the last couple of years, materials manufacturers have released a number of different fire compliant materials onto the market, and it's growing all the time. Still quite limited for SLS, but for FFF, it's definitely progressed well. And the other advancement is the publication of engineering data on the materials and the processes.
Interesting.
So the research institutes and the system manufacturers have had time to do the test to get the background data that we need, that we can then use for the fundamental assessments for our design.
Okay, all right. Interesting. Thanks, Martin. Any specific advancement, Anthony, that have helped reshaping your business model?
I would agree with both of the points that Martin made. I would also add the machine stability,
Okay.
so machine consistency. As I mentioned, kind of that process window. In the years past, that window was really large, like not an optimized structure, which you can really count on it. You had to open it up so wide that it then becomes the cost, again, bringing the cost back in, it becomes such a disadvantage because you might have to scrap parts. Now that process window is starting to narrow, where I'm really confident whenever I put a part onto a machine, it's going to print as I expect to the quality, and I can repeat that over and over and over again. So still, we have ways to go on that, so that it's still being optimized, still improving, but really we've come a long way in the past 5 years.
Okay. All right. I see. And at the software level, I realized that software solutions, that we increasingly have, software solutions powered by AI. And my concern here is that for these software solutions, AI is just like a selling point that those software companies use, to sell their product. So I'm curious to know if it really advances or disrupt or enhance the product design process, or you see, Anthony?
Yeah. Especially kind of like in the recent months, AI is kind of one of those big hit words that really gets tagged onto anything, even if it's not really AI, right? So the question is, like, is it impactful to our space, specifically in software? Absolutely. I think it's going to have a space. I still don't know exactly where, but I think it's really going to be impactful. One of the areas that I look to, and you're starting to see a little bit, companies do this a little bit, is just predictive failures. How do you make sure that if you're halfway through a build and there's a defect that occurs, that it alerts you and you don't have to continue the build for days more potentially, right? How do you kind of stop it there, restart the build, and kind of continue? So that's one of the, I would say, sort of near-term ones that's low-hanging fruit for AI to be able to support and solve is around predictive failure models. But to that point, you have to feed the system. You have to feed that AI structure. You need a lot of iterations to kind of feed that network to make it learn so it knows your failures, right? So is it going to happen tomorrow? No, but
No.
I know that it's going to. And again, one of the many future things that how we see the landscape changing in additive, that AI is going to impact it, to be determined on what really that looks like.
So right now it's just about communication. Actually, people do not really leverage it.
I think we're leveraging it more and more in the development sense.
Okay.
We have not used it on an industrial scale. We're
Mhm.
starting to. We have an AI, an advanced technologies AI team within Wabtec that they've built us some tools on how we can use that and assess our layer images, for instance.
Mhm.
It's still more of a reactive mechanism than a
Yes.
proactive, but we're proving that out like on more of the lab scale. Once
Mhm.
we prove that out, then we can plug it into our process and make it kind of an industrial step along the way.
Mhm.
So we're working ourselves on how do we do that. I think the software companies, I know that they are doing a lot of that prep work, but it's a lot more slow moving. It takes a
Mhm.
long time to kind of build that up and educate your AI network, the software itself, to be able
Mhm.
to be really useful.
Okay, I see. Martin, do you have a specific, insight into this question? No?
Not really. I think, as he said, it is more on the process side, the machine side, and we don't have our own machines. We don't
Yeah.
develop machines. We're more the design side and the people management, the change
Mm-hmm.
management side. So I could see that in the future, some software package design packages,
Mm-hmm.
structure assessment packages might be able to leverage AI to to allow us to optimize
Mm-hmm.
shapes more effectively,
Okay.
like the generative design, but the next stage on from that. Um, but at the moment, no, we don't see anything. We're
All
not
right.
working that way.
All right. So Martin, you mentioned just before that materials were like a critical, item that has really helped reshape, your business model in AM. That can help reshape a business model in AM, especially in this industry. Do you have like another example of of applications that you can share where materials have been a solution to a critical challenge?
Um, yeah, the main one is in fire compliant thermoplastics. The materials has brought they're bringing the cost down
Mhm.
primarily. It's not making generally not giving us anything new, although there are developments right now that are. So this is a very unassuming part, but it's a thermoset polymer elastomer that's
Mhm.
being developed by a company. Then it's one that will have a very longevity, a good life, which means it's usable in rail. So
Mhm.
that is elastomers by themselves are a whole area we can't yet leverage with additive. So once this is fully industrialized, then this will be a game changer and introduce a whole new range of things we could look at.
Okay. All right. And both of you mentioned cost, as like has has really the, I don't want to say the disadvantage, but really as the key element that actually slows down the adoption of a lot of AM process. Uh, do you think, as an end user, and I believe it is, if it slows down the adoption of AM processes, it somehow also affects the end. I mean, the price of the end part. So, as a final user, do you think that you have a part to play? A role to play in this debate, Anthony?
Sure. Yeah. Um, yes, we definitely have a role to play as the users of the equipment. We need to one, develop an optimal structure, kind of our own process of like, how do we create the most cost competitive parts
Mm-hmm.
that still work, right? Obviously, you can't take shortcuts. You need to still achieve the goal at hand of getting a successful part. But are there things you could do to bring cost out of it? That's stuff we do literally every day. We look at business cases. We say, could we take this step out? Like, what does that do? Just kind of do a risk reward analysis to see like, does this result in us not being able to perform like the application, or is it a acceptable risk to take on to lower that cost barrier a little bit? So just optimizing the cost structure is definitely one that we have to play. Another one is making sure the machine OEMs, so we purchase machines, that they're aware of the challenges that we're facing. What do we want to see in the next generation of machines? Obviously, we all want it cheaper, but if we could make it go faster, that would decrease my cost as well, because you're increasing throughput. So like there's some knobs you could turn to decrease that cost, but it comes back to like, are we making sure we have one voice to the OEMs so that they're aware of what their customers need as the next generation of machines? Because really, it always goes back to like, well, it's expensive because the machines are expensive.
Sure.
Machines are expensive because it's a really fast cycle that these OEMs just turned to develop this machine, right? So, what is the next wish list that we have to make sure that we as users are successful is something that we can play in as well.
Yes, Martin, what do you think about that? What will be your role in this equation?
So as designers of these parts, we need to think carefully about the process the best process to use, because there's definitely the cost of printing, there's the cost of material, but there's also the cost of finishing the part.
Yeah.
So going back to my simple armrest, this one was printed with FFF Ultem, so the surface finish was really bad, and it cost as much to finish and paint it as it did to print it in the first place. So if we can redesign it to reduce the weight and use a different material, different process that gives it a much better finish, we can significantly reduce the costs through our choice.
Yeah.
The same applies with, if we don't even need to do anything at all to it, it just comes perfectly out of the machine.
Yeah.
You've halved the cost straight away.
Yeah.
So there's that side of it. There's also the cost of the part itself isn't necessarily the overriding factor, because additive could get you something very quickly. So you could save a lot of money by supplying a critical spare that stopped a train. If you can get that to the maintainer in 2 weeks rather than 3 months, even though the part is maybe 10 times more expensive than the original part, they still save a huge amount of money because they're getting the train back into service quicker.
Yeah. Right.
So there's two sides to the cost thing.
Yes. Yeah.
And it's all within our control as the design authority, and choosing which process and material to use in there.
Yeah, I didn't see it that way, but that's right. That's right. Yeah, there's a question in the Q&A chat for us. Do you think we already have 10% of parts already 3D printable in a train? I like these questions because it kind of, it will open up, on some of the personal insights and goals each of your company has in the additive manufacturing industry. So I will let Anthony start.
So looking at kind of our two main segments, freight, locomotive, and then transit components, kind of splitting those up.
Okay.
On the freight equipment side, big, heavy industrial components, right? They're very large. Again, they've been optimized in their manufacturing techniques for decades and decades. I do not believe that there's 10% of the components are printable. However, the components that are printable on there are extremely impactful. Some examples of that are around fuel delivery. If I can improve my fuel burn a few percentage points, that is instrumental. Like that is extremely, extremely important for my customers.
Yeah.
Fuel is one of their biggest cost drivers. So even if there's just one part on this whole engine that's printed, yet it's improving their fuel efficiency, huge. That's game changing, right?
Yeah.
So that's the stuff that we're focusing on the freight locomotive side. How do I really solve my customers' problems? It's not about like a percentage or number of parts. It's about of like what are the critical parts that really move the needle.
Mm-hmm.
On the transit side, there might be 10% that we sell that are printable right now. We're still working through those of like, should we do it though? Is it make sense? Is it economical? We're finding those areas that again move the needle, and we found a lot of them. As I mentioned, there's many parts that we've printed that are on asset now. One of the exciting ones that we're printing are around brake manifolds.
Mm-hmm.
It's a design that we've really made the same way since the namesake of our company, George Westinghouse, has made
Yeah.
it about 100 years ago. You're taking several chunks of aluminum, you're milling it down, gluing it together. We've done 4 brake panels. The average is about 30 parts down to 1. So
Mm-hmm.
assembly consolidation. It's decreasing the weight savings of a transit operator, huge. It's improving the performance. So all those additive check boxes that we try to look at, it's checking a lot of those. So that's one of the flagship parts that we have on the transit side that it's really exciting.
Okay. All right. Awesome. Interesting. Martin?
I'll look at it in a different perspective.
Oh, I
So,
like tell us.
so we do a lot of work with old trains. The trains running around in the UK, you can get some that are 40 years old that are still being upgraded and maintained. So
Mm-hmm.
of those, they were designed for traditional manufacturing methods. So trying to print 10% of those isn't really viable, because you're trying to copy something that's traditionally made and optimized for that method with a new technology that has different advantages, but it's not necessarily the best technology for replicating a cast part, for example. You're better off making a cast part as a casting than printing it. However, for new trains, there's definitely a big push to increase the number of printable parts in it. And I
Okay.
know of at least 2 new build tenders in Europe where the contract has stated that the supplier must include 10% of the parts as being suitable for 3D printing digital manufacturing. The idea being, the purpose being to increase the ease of getting those parts when the trains get older,
Mm-hmm.
to increase the flexibility of printing the spares, and also the supply chain issue and circularity, environmental benefit that you get from 3D printing. So those are the reasons why they're now putting them in contracts, and they are in the contracts now.
So for DB, that's a goal actually to reach these 10% of what?
Yes, definitely
Okay.
is. Yes.
Okay, I see. When do you think, I mean, that you'll be able to achieve it, if it makes sense?
I think, yeah, it needs the new build to be designed in that way to
Okay.
be able to then get there, because it won't work with a 40-year-old train. It just isn't cost effective at the moment to do that.
Okay. Okay. Okay, I'll see. And I think for Wabtec, I mean, Wabtec plans to use AM to produce over 25,000 of parts by 2025. That's correct, right?
Yeah, that's correct. Actually, I mentioned it earlier, so we've actually already surpassed that. It was a goal that we
Ah,
set in 2019, and there was a lot of changes. Obviously, the kind of the GE Transportation Wabtec merger at the time,
mm-hmm,
getting our labs stood up around that same time frame,
mm-hmm.
and that was a very lofty goal. Because of kind of the awareness increased so much around additive, we already surpassed that. We're at 40,000 parts that are on
Awesome.
asset already.
That's
So
so cool.
a lot of those are polymers. We're looking, okay, what's next? What's the next milestone that we want to achieve?
Maybe
Um,
metals.
I'm sorry.
Maybe metal.
Metal for sure, yeah. So a part of that 40,000 is metal, but a lower number. Metal is definitely, I would say, a stronger strategic path for us, and how do we better increase this to create a bigger impact for us and our customers for sure.
Mm-hmm.
Yeah, so exciting. We actually surpassed that end of last year, end of 2022.
That's super good. I really look forward to seeing, what will be your next goal moving forward. So
Absolutely. Yeah.
hopefully you will share it with us. So this is almost the end. I am just going to ask if you have any last comments that you would like to share. Do you have any questions, Martin? Do you have any questions for Anthony or vice versa?
Martin, I was going to ask, you mentioned about there only being 2 fire and smoke materials initially, but it's starting to really develop. Can you characterize that any more? What have been like the strong runners of materials that you've utilized over the past year or so, and kind of what's the next one?
So the thermoplastic materials, the Ultems are still, or the PEIs to give their proper name, are still the number one for the full fire compliance, because I think it's impossible to get a nylon type material to meet the top levels. But a lot of the work we're doing doesn't need that full fire compliance, so we are still so the Onyx, the Mark Forged Onyx fire retardant material is actually quite a good one for us at the moment. Price point and build size for interior components. And we're also trying to just use stuff that doesn't even have any fire compliance, like MGF, because it's just so easy and quick to get the parts, and the finish is really good, that it's just perfect for those little bits that are missing from the interior, little plugs, little switches, bits and pieces that are just a pain for the supply chain, for the maintenance guys to deal with, and we can just get them parts really quickly and easily.
Okay. Well, that's it. Do you have any last thoughts that you would like to share? Any last thoughts on the panel, on this conversation, and on how the industry will move forward this year?
I just want to say that our next big push is going to be in DED, laser-based and wire arc. That's what we're going to look at really big this year. And just interested to know if, Anthony, if you're looking at purchasing such machines as well.
Okay.
Yeah, it's something that we're always evaluating, kind of what's the next machine technology. Like you mentioned, it's not just kind of like a static, you move into the industry or a specific machine, but just kind of continuing to take the pulse of your customers and what they're asking for, and balance that against where's the technology at. So I don't know if it's this year. If you ask me today, I don't think it is, but hopefully that changes tomorrow and we get a bunch of breakthrough applications that really just make sense for it. DED though is definitely, I would say, maybe the next wave, next technology out there. Binder jet is one that we've evaluated a lot over the past several years. We'll continue evaluating where it makes sense. I think that application pool has narrowed a little bit for us around binder jet, but it's still a very interesting technology, and one that, again, if you look a decade plus out, I'm sure that's going to impact us to a degree, but not sure on the amount of applications around that.
All right. Thank you very much, gentlemen. Well, on these good notes, this is the end of our panel. First, I would like to thank our audience. I recognize some of the names. So thank you for listening to us, for listening to the insight into the world of additive manufacturing technologies. Thank you, Martin and Anthony, for joining us during this conversation. I appreciate that you took the time to share your expertise, your thought, and your experience, on this technology. I will give you, for the audience, I will invite you. I would like to invite you to stay tuned for the next session that will be announced soon. It will certainly be on March. Second week of March. So stay tuned and stay safe wherever you are in the world. Thank you very much, gentlemen, for joining us. I will now close the panel. Wish you a very great end of day and a nice day to you, Anthony, because it's still the beginning of the day for you.
Thank you all.
Yes, thanks.
Thank you very much.
Have a nice day.
Okay.